Today I'll be explaining how selection violates Hardy Weinberg equilibrium in a population of fish. Here's my population of fish. My population is of 500, but this is just a small representation. So of my population, I have 240 blues. I just did 24, 180 pink, and 80 green fish. There are genotypes, phenotypes, and number of individuals. First, I will need to calculate the allele frequencies before selection. So I take the total number of individuals for our first genotype, big A, and then because this has a big A and a little a, we want half of this population. So we multiply this one because it's diploid plus 240 divided by the population times 2, and that gives you 0.6, and do the same thing but with the little a, and then the other half of this times 4, and that gives you our gametic array. Next, we can take these and do a Punnett square to figure out the genotypic array for each one. That gives us this, and I highlighted what color matches. So then we get 0.36 AA, 0.48 big A, little a, and then 0.16 little a, and it's at equilibrium because it equals 1. And also, to be at Hardy Weinberg equilibrium, all of this, which is what this is, equals 1. It is an infinitely large population. 500 is a large population. There's random mating, no selection, no migration, and no mutations. And to figure out the number of individuals with each genotype and genotype, you can multiply our genotypic array by the population number. This is another way to figure out the allele frequency once you have your genotypic array. Now let's look at our population after selection. 3 types of selection. We are going to be focusing on the stabilizing. So after a long period of time, and I'll explain this afterwards as well, intermediate phenotypes are more fit than extreme ones, aka our blue fish are going to survive better than the other fish, the pink and the green fish, because in this case the blue fish camouflage better in the ocean, so our predator that came in isn't going to eat those as much, so they survive better. Our heterozygous genotypes are favored, yet both alleles will remain in the population. So our fitness is the ability to survive and reproduce. These are our fitnesses for each genotype. So we multiply our original genotypic frequencies by our fitness and get this new array. And this is no longer in equilibrium because this equals 1.016, which is not 1. So you divide it by that, and that'll give you our new genotypic array. And then to figure out the amount of individuals with each phenotype and genotype, you can multiply it by our population and get these numbers. And after a long period of time, see that the numbers changed. Our pink fish went down. Our blue fish went down a little bit, but over time, this is what is favored. Our bell curve will get narrower and narrower in favor of our heterozygous. And see the green went down as well. What happened with my population is a new predator came into this environment, came through, and decided that pink and greens were easier to eat, and the blues survive better because of their camouflage. After a long period of time, all 3 alleles will remain, but heterozygotes are favored.